Hello all, welcome to the video. This video we are going to talk about the requirements of the convolution neural network. There were many questions like when should we use convolution neural network? Given a problem, say for example identification of a digit from a minutes dataset, should I use the traditional artificial neural network or the conventional machine learning or the convolution neural network to identify the digit? I can solve the problem with an ANN, ML as well as a CNN. So this video we are going to talk about the requirements or the need of a CNN in solving a correct problem. Based upon the underlying problem, you have to choose your model. So that is the objective of today's video. So without waste of time, let me get into the video. Before getting into the actual concept of the requirements of a CNN, we are going to discuss image processing, and feeding an image into a neural network. Also, feeding an image into a traditional machine learning model. Let us discuss what actually happens. And then we'll understand why CNN is superior or better when compared to neural network and machine learning model. An image is nothing but a set of numbers to a computer. An image is not a picture, it is just mere numbers to a computer. Let it be a grayscale image or let it be a color image. It is just mere numbers. For example, a grayscale image is represented as a 2D matrix. Each value will be pixel intensities ranging from 0 to 255, where 0 represents black and 255 represents white. For example, this is an image for a computer. The rows and the columns will be the height and the width of the image. In the case of a color image, it is represented as a 3D matrix, where the shape is nothing but the height cross width cross the 3 channels. The 3 channels are nothing but red, green and blue. For example, 255, 0, 0 is an absolute red. So color images are mere just 3 grayscale images stacked together. Hope you understand what is an image. So how big is an image? The dimension of the image. If the image size is 224 into 224 into 3, the size or the dimension of the image is 150,000. So one small image already is living in this much big dimension. So now let's see what happens when I feed an image into a neural network. Now what is a neural network? We have already seen in the previous videos the detailed concept of neural networks. They are inspired by the biological neurons and they consist of a set of input layers, output layers and hidden layers. They learn based upon weights. This is a simple neural equation which gives you the output. Actually, how come images are processed by the neural networks? Images will be first flattened. Neural networks expects an input in the form of a 1D vector. So we need to convert the image into a one-dimensional vector. So what is the problem with flattening of the image? The spatial relationships of the image will be destroyed. The neighboring pixels will lose their meanings. So they don't understand that these are the neighboring pixels of this particular pixel. So the total network forgets that these pixels were next to each other. So it's a real problem with the neural network. The problems could be classified into 3. Number 1 is too many parameters. A fully connected layer means millions of weights. It requires huge memory and leads to overfitting maybe. And the network has no spatial understanding. The edges, the textures, shapes might be lost in transit. The network has no translational invariance. The same object in different position might lead to different input. The handwritten digit 5, if suppose I am rotating the image, that might lead to a wrong input. So the network learns simple numbers, not the vision. So this is the drawback of a neural network. So what does the network actually learn? It tries to detect patterns, but the network will not have any idea regarding the edges, corners, textures and shapes. So this creates a fundamental requirement for the need for a structure. So now, the need for a structure. We need a structure. So why basically these neural networks fail in image processing? Because images are high dimensional and are very spatial. For example, you take a image of a cat, this one, a grayscale image. The size of the image is 1024. The input layers are 1024 neurons. I assume that I have 100 hidden layers neurons. So already we have 1024 into 100. So 102400 weights. In the case of a color image, say for example, the inputs will be 3072 inputs, which leads to millions of parameters. So you understand the issue. There are too many parameters, no spatial understanding, and sensitive to positions. I mean to say, if I change the position, it might give a wrong output. Overfitting is a problem. So an artificial neural network sees an image as a long list of numbers. It doesn't see the image as a picture. Come on, next. Like, why the traditional machine learning model also fails in image processing? You would have tried with SVM, KNN, random forest. These are classical traditional machine learning approaches. But the problem with these machine learning models is that they need manual feature extraction. So let us take an example of face detection. Before CNN, researchers would extract the edges, corners, textures, shapes using some kind of SIFT, HOG or LBP algorithms. And then they feed these to the machine learning classifier. This is a tremendous amount of work. Again, machine learning models have a lot of issues. Features are handcrafted, they are not adaptive, they are not scalable, and the total pipeline of the machine learning model itself is very complex. So machine learning could classify only what humans could describe. And that is where came CNN, which solved all problems together. So let me take the same old example of an input digit 5 from the minutes dataset. In case of ANN approach, like already we saw, the input is 784 pixels. This will treat each pixel very independently. So even if I slightly rotate, it leads to wrong prediction. Machine learning approach, I should extract the edges manually, then feed it into a machine learning model like SVM or KNN or whatever it might be. Once the handwriting is different, the features will mismatch. Whereas CNN has a convolution layer, deeper convolution layer, and a final layer which could learn all the features automatically. It understands the spatial structure. It possesses translational invariance, and it needs only fewer number of parameters due to the concept called weight sharing. So these make CNN so robust, and it solves all the previous problems mentioned with the traditional machine learning approach and the neural network approach. The CNN learns the image the way human visual system does. Golden rule. From simple patterns even to complex meanings. So this would have made you understand why CNN is important, why CNN is required, and what is the need for a CNN to use a CNN when compared to a machine learning model and a neural network model. What can a CNN do and what not a machine learning model and an artificial neural network model? CNN has 4 important concepts. Number 1, local receptive fields, which captures the spatial relationships. And number 2 is weight sharing mechanisms that reduces the actual number of parameters. Number 3 is hierarchical learning that learns patterns themselves automatically, and pooling mechanisms that handles even small shifts and noise. To summarize, artificial neural networks sees images as mere numbers. Machine learning models sees features designed by humans. whereas CNN sees patterns and meanings. CNN did not replace intelligence, it has replaced assumptions. So I hope that this video would definitely help even a novice beginner to understand the importance of CNN. So if there are any doubts, please post it in the chat box. I'll be happy to explain. The next video will be talking about the working principle of a CNN followed by a manual example of CNN from scratch. Thank you so much.